in process. Record in processing. Okay, dah record. Saya akan present slide. So again, everybody, welcome back to our main business. As a civil engineer, you must understand about the engineering survey, because engineering survey is really important nowadays. And this engineering survey to make sure that you guide the people, especially your subordinate or your boss, your investor, is based on what we call it the right procedure to construct any building on land. Okay, we are continue back at we call it slide number 17. This is the last one, 16. I think you still remember the magnetic north, true north, magnetic north, and then what is we call it true bearing, reverse circle bearing, and so on. We finish on this business. I think this one is 16 numbers of pages. Now we go for, we call it travel survey. So now we go to the travel survey. Is we call it the lines, or we call it the survey line is invisible. It's connected by two stone on lands, and this travel survey actually try to help you to identify your boundary, your land boundary. You cannot encroach. We call it the adjacent boundary. We call it your beside, because according to national land codes, is a marker, is a lines to mark that is okay your land ownership. So mean that if your name put in on signs, it belong to you. But if you encroach beside your lots, but beside your traverse, you put a building, so the owner will sue you on court. They have the right. So, and then of course, remember here, this we call it traverse survey. Also, you can calculate the area. And this area normally you not understand, but is in a meter square, or it may be in a foot square, and maybe in a hectare, maybe in last time we call it relong, acre, and so on. So this value of the land based on land property is represented by the area. Okay, by the area. And this area must have boundary. And this boundary to determine the size of your lands. And this boundary or the travel survey representing the boundary that shows the copyright or the ownership of the lands belong to you or your family or your company. The company also can put their name, we call it on the land grant. Okay, so the travel survey you cannot see on land, but you can see just fine. We call it the batu sempadan. We call it one stone make it from concrete, spherical. The height is 1 foot, diameter is around 4 inch to 3 inch, okay, diameter. So you plant it at the vertex, di bucu tanah, or at the vertex of land. So from that vertex of line, that we call it the vertex of lands, we are measuring this, we call it the stone that we're planting at the penjuru tanah, or we call it at the vertex of the land. So it will cover that normally a closed traverse where we can know we start from first point and then we come back to the last point that we know. And this one including with the what you learn in compass, what you learn in tenolite last time. We call it the line is a bearings, and we have a distance. And you know, if you have two line connected, they have two bearings, they forms two, included angle and included angle and excluded angle. So sudut dalam dan sudut luar. We will see after this, okay? So if you look at this one, okay, if you look at this one, so first maybe I will try, we call it to take this opportunity, okay, right? Try to draw It is a traverse survey. And number one, in order to survey any parcel of land, parcel means lot of land, parcel, it's not something like the parcel only for the posting. It's a posting COD, no. It's a parcel means the land of land. Two distinct operations are required, namely a framework survey. Framework survey means that you have, we call it we call it a concrete marker at the vertex of the buildings, the vertex of the land, and this is the station, third station is from fourth station, and then coming back to the fifth, and then coming back to station number one. Mean that we have this is, we call it our land lot, our land lot, or our land plot. So normally in land lot we have number of land lot, or we call it plot, and we call it the ownership. Who is the owner? Normally we have name, we have address, and IC number. And of course, we also have here in we call it in the land grant. You can see this is the area, and sometimes they will put also, we call it how much the fee you should pay to the government. So mean that cukai tanah, okay, cukai tanah, land excise, okay. So this is, we call it a frame survey. And in detail of, because we have the project, we are doing a project, sometimes we may take site clearance, okay. So let me, we call it erase this one first to make sure that you understand. Erase this one, okay. Again, I draw back. So what I try to do here is, if you want to construct the building here, so before you construct, normally maybe this one you have, we call it bushes, you have a tree, or maybe you have streams, you know, small streams. So you want to eliminate, we call it this stream. You want to eliminate this tree. Okay? So when you want to eliminate, of course we need quantify what is the biggest, or we call it the size of the trunk of tree. What is the width of the river, the small river? You want to, we call it, do the filling. So this is the detail. This too is a detailed survey. So that's why in survey, first we have a framework A, B, C, D, 1, 2, 3, 4, 5. Number two, you have a detailed survey. For example, that you have tree, you have river, maybe you have lamppost, maybe you can have, we call it a bunker, you know, bunker, kubu lama. Untuk berperang maybe you have, we call it something like last time you built up 20 years ago, the small house, we call it store. So you want to eliminate. So you must mapping based on the detailed survey. So detailed survey again, maybe a lamppost, maybe a small river, maybe a lake, a tree, okay, maybe a bushes or shrubs, okay. But you are mapping it to make sure that the site you want to clear, you know the quantity, how much, we call it, actually reflect based on your site clearance. So we are consider inside, we call it site clearance or site clearing. Okay, we go slide number 18. Again, a framework survey consists of series straight line, a series of straight line, station A to station B, station 1 to station 2 is straight line, okay, arranged in the form of triangles, linear survey. So at least you have a triangle. This is the small one. So normally you have, we call it like a trapezoid or pentagons. You have like nonagons, and maybe your land is a very crucial, something like this. Maybe you have 20 points, but it's a linear one. Okay, based on the site and so on. Okay, I think you understand this one. Before next we go to, we call it more detail. I should erase this one, but I think you understand, because last time you are doing, we call it a leveling survey, and some parts we call it about theodolite. Then theodolite, you measure the angle. I set up, we call it the 5 station. You still remember at Laman Perdana? This is all the straight lines, and this is one. That's what is comply whatever is stated here. A framework survey consists of series of straight line arranged in form of triangle, ellipse, linear survey, polygons, closed traverse survey, or vector, open traverse survey. So what is the difference between open and closed? So normally open, people say like this: we have station 1, we are going to station 2, we are going to station 3, we are going to station 4, we are going to station 5. So people say this one is closed traverse survey. Okay, because it start from 1, going to 2, going to 3, going to 4, going to 5, coming back to number 1. And sometimes people say vector is open traverse like this. So we have station 1, station 2, station 3, station 4, station 5. 1, 2, 3, 4, 5. So this one is a open traverse. This one is closed traverse. Actually, this definition is wrong. Why? According to survey like this. If you start from station 1, start from here, you're going to station number 2, going to number 3, going to number 4, going to number 5, going to number 1 back. So this one, they say that, yes, there is the closed traverse, but you start from known point. You know from known point. For example, you know this one is the coordinate like 100 northing, 100 easting. So we coming back to station number 1. So we know that 100 northing and easting. So this one close traverse. Okay, so this one the right definition. You start from no point, you coming back to the known point. What you know? Actually, you know the coordinate. You know about the station. Maybe this one station 1. Okay? But here, it's very complicated. You start from point 1, going to point 2, going to point 3, going to point 4, going to point 5. We call it open traverse. That is right. How this open traverse to become a closed traverse like this? You know that this one, you know coordinate is 100, 100. And you know this, we call it, this one is 500, 500. The coordinate, nothing and this thing. You know. You know this one based on your GPS survey maybe. Alright? So you know this value. So when you do a survey from point 1 to point 2, point 3 going back to point 3, 3 going to back point 4, 4 going to back point 5. So from known point to coming back to known point, this one. So this one also we call it a closed traverse. So the closed traverse means you start to start and finish to finish the point you know the coordinates or the station number. Is it clear? Alright. Okay. I'm coming back. So we call it to number 2, the point. I think you understand this one. You must remember, student normally the C we call it the form of the line, and then the line connected by extension. If closed traverse, open traverse, they just draw. Yes, you can draw, but the mark is half. If the mark full 1, you must say that from station 1, you know coordinate like this, 100, 100, you coming back to the station 1. Again, you know that 100, 100, station 1. So that is, we call it closed traverse. Okay, it's open traverse, you start from, you don't know about first point at station 1, and then you finish at station 5, especially open traverse, you also don't know the coordinate, so mean that open traverse. Alright, now we call it the second point. A traverse survey consists of a series of survey lines. Survey lines, you still remember that survey line? These are the series of the survey line. Based on how many stones we have, so this stone is connected by line. So maybe you're traversing like this. We don't know. Okay. So here we have a straight line, and then you have, we call it bearing and distance. Connected to each other, we connect, and each line having length and direction. So we have this one maybe 20 degree, 10 minute, 0 second. So the length is 10 meter. So we have a bearing here, we have a distance, and all this one must have a length. bearing, bearing, and bearing, and bearing, and bearing, and bearing, must have distance, distance. This one bearing, another one is a distance. So we have B and D, bearing, and distance. Okay, and one. So this is again. Still remember that I said to you is a torrent is invented in Australia. Ownership. So you have the names, you have the bearing, you have the distance, address, IC also put, and the grant normally based on states office, state land office. So if you have the land from Perak, the grant is different. If you have the lands we call it in Kedah, the grant also different shape, and the fee, or we call it the land fee, also different based on state. It's not based on the federal government. So that's why we say that anything related to land is based on state matter. It's not from the federal matter. Okay, when you look at this one, what is your comment? Is it open traverse? Of course, if you don't know about point A and going back to C. But if you know that from A is the 100 nothing existing, and this one you know that 500 nothing existing for the station C, we cannot say this one open traverse. We say that closed traverse. Again, so normally this one you have two definition. Open traverse is different, closed traverse is different. Even though this one is the straight line, same shape. So the difference is that you know the point A and point C coordinate. If you know earlier, mean that closed traverse. If you don't know, we call it open traverse. Okay. So again, like this one, we are going to start from station A. Then we go to this one B, C, D, and then coming back. So it means that you can become a closed traverse or become an open traverse. If you know the point A, for example, is 100 nothing existing, or we call it 150 and 150 nothing existing for point A, right? For point A, so the point is here, right? So when you are doing a survey like this, you're coming back to point A, you know this coordinate, right? You know this coordinate, right? So mean that this one is a closed traverse. So definition closed and open traverse based on either you know the start and the finish points that you are measure the line or the to make bearing and distance. Okay, so basic principle of traversing. Number one, basic principle of traversing. When you're doing a survey, in traversing, you must make sure A, B, C, D is in your minds to aware. Number one, measuring the slope length. Number two, measuring the angle of gradient of every line. Mean that you must measure based on compass or based on total station about horizontal angle, or if they need vertical angle, you can measure. Measuring clockwise horizontal angle between adjacent lines. So mean that if you have like this, point A going to point B traverse, point C going to point D, coming back to point A. So your survey works must flow like this. Okay, you go A, B, C, D, going to back to A. You cannot opposite. Yes, of course, you can opposite if you understand well. We call it is the A1 level. So for the basic one for you, we call it advise you to follow the clockwise directions to move your equipment from A to B, A to B, B to C, C to D. Alright, so C cover, B cover, A also cover, measuring the bearing. And when you're measuring the bearing, for example, this one station A and point B, you must have, we call it, number one is degree, 45 degree. Number two is minute. Number three is second. But you remember, if this one is tenolite or total station, but if using a compass, You don't have the second. You don't have a second. Not only we have 45 degree, 20 minute. This one, something like this. So we don't have second for compass because the compass, the indicator is not really like digital, like total station or tenolite. So total station and tenolite can give you a very small one and maybe around 20 seconds when it moves very smoothly in horizontal and vertical. And sometimes they're going down, so the tenolite in horizontal they can move around 1 second, 2 seconds, 3 seconds, very decimal one. This one is the accuracy. The more expensive about, we call it tenolite and total station, it can give you the high accuracy. So that is, we call it the basic knowledge that you should have. Okay. Okay, measuring the slope. I want to explain this one. Okay, first I will rub this one. We go to eraser. How you measuring the slope length? I think most of you, I already, we call it, remember that you have a practical works in front of your Islamic center. I always say that please lift up your tape because your tape, okay, you must go straight, you must stretch it until straight and must be level flat. And normally student, they make a fall because because um, because they try to, we call it a measure in a slope, same with they are measuring the flat land, but actually that is totally wrong. Okay, I will show you the flat land first. So we are in same topics about the basic principle, all right, and we are moving to the back to number, we call it number A. If this one is flat and this one is slope, this one is your point A, this one is your point B, and something like this. This one is point B, this one is point A, but this one is flat and this one is slope. So remember, normally we pull your tape like this. So finish, no problem. Between pack and pack. You still remember your pack here? Your wooden packs, you make it in the red color normally on or in orange. But when come to slope, something like this, so you must measure like this. So the very critical this area, because if this one is maybe 6 foot high, 6 foot high, so you must, we call it, hold and hang the tapes and make it straight. Okay, you must go straight. So mean that your hand left and right must straight up and then hold, and sometimes give you a pressure. You feel like something like uneasy, kabas and so on. But this one is the right method. Normally students measure like this. This is wrong. They follow the topography. We not measure the slope distance. We measure the horizontal distance. We measure the horizontal distance. We not measure the slope distance. This one is slope distance. So this one right, this one wrong. In basic principle of traversing. Okay, next. We are moving. Next slide. Wait, Oh, so very slow. Slide number 22. Okay, slide number 22. Okay. All right. In travel survey, the duty of surveyor are, okay, what is your duty as surveyor? Sometimes you are not the surveyor, but you are the in charge of surveyor. So what is your duty? Number one, to select suitable station. if you want to put a station A, but the station A is at not suitable area, for example, that area normally has a big holes and can make, we call it danger to you, avoid to set up a station A at that point. Maybe you know that this is, we call it, that station is under clay. And on top of clay, they fill up with a lot of water, maybe due to the rainfall. So don't put station A on that clay soil which induced by rainfall and the water ponding on the top of the station location. Okay, number two, to measure the distance between the station. So you must remember to measure the distance must be horizontal distance. Don't go for the slope distance. So you make sure that the tape is must be in the straight one. You must stress something like this to make sure this one is as straight, right, in the horizontal. Okay, number three, so you might also, to make sure your surveyor maybe is under you, you are become resident engineer, or maybe your, we call it, your salary is that time is 25,000 or above. So you must attend and move the sighting target from station to station. Okay, mean that as a surveyor, you must go to the every station. If, for example, you have station A, B, C, D, and E, 1, 2, 3, 4, and 5, and 6, you must go all the station and see either the station, for example, station 2 can see station 1, station 2 can see the station 3. And you must, we call it, tear out the obstacle. Maybe you have a small bushes here, so you must cut it. Alright, so this is one of the example. To measure and record the angles, if you will call it to measure, for example, that point A going to point B, and you measure the angle by compass. This one is magnetic north, MN. So your angle is 45 degree 0 minute. So you don't have second because the compass is low accuracy and it's very cheap. They don't have the capability to read, we call it a seconds in the reading of angle measurement. And then when you get this one, this angle, you must record. You must write in the booking system. So you write here, this one. So you write here. So for example, is 45 degree, 20 minutes. Okay? All right? So let me be call it to reduce this one first. Okay. All right. So we call it, we have number 4. So draw. We call it this one drawing. To measure and record the angles. And then to reference the station for further use. For further use. To reference the station, that if you have this point, 1, 2, 3, 4, 5. So you don't know which station A, we know station B. So you must level on your ground and you must record in your sketching. For example, this one station 1, you level it 1 in the pack, at the packs, and this one is station number 2. You also sketch it in your record books. In your record book. This one is record book. Okay, all right. And then you also something that you have, we call it spherical wooden packs or concrete. So you write here is a point A. So to make sure that you remember when you see this marker on land, and of course the land's marker you will leave out maybe for the 20 years, and you don't know that maybe we call it 40 years. And again, you're coming back, you know, wow, this one is station A. And very good, you put, we call it a date too. Date. Okay, 31st May 69, for example. Because they know either, we call it that marker is original and still fixed and viable to use. All right. Okay, we finish on this one and then we go for next. surveyor, and this one. The position of station are governing by the following factors. So if you want to choose a station, what is a station? Station A, station B, station C, station D, station E. So why station is very important? So based on station, you can get bearing and distance. This one is station A, station B, C, D, and E. So make sure that easy measuring condition mean that you choose station A. It's not something like you have a big tree here and give obstacle to observe to point B. It's a mean that you avoid these situations and make sure that you have choose a station, for example E. You can see D, you can see A, intervisible, right? Number two is avoid a short line. For example, like this. You have station A, station B, C, D, E, F. A and B is very small. This one A and B is very small. So avoid this situation. So a short traverse line. So C, station should be chosen so that the actual station mark can be cited. So when you mark a station A, B, C, D, and E, normally we have peg, right? So we color in, we call it something like yellow, red, orange, to make sure that the marker you can see and very easy to search for, all right? The station should never to some permanent object such as a tree. For example, that there's a small tree here, small tree here. You say that this one is point B. It's wrong because a small tree after next 10 years, the small tree become the adult tree. The trunk maybe we call it 10 mm at the time. After we call it 10 years, is maybe the trunk is maybe 300 mm. Okay, or maybe we call it 1 meter. So we call it the event, the we call it the enlargement of the trunk based on the period due to because the suction of water and minerals, and that the center point cannot become a center anymore because the diameter of trunk or batang pokok become bigger from 10 cm to become 1 meter. So avoid this one. Tree, avoid something like lamppost. We must have a permanent, and normally we put a concrete spherical blocks. All right. So I finished slide number 23. We go for slide 24. Okay, this is slide 24. Okay, referencing travel stations. So mean that referencing travel station mean that travel station often must be found and reoccupied months or even years after they are established. I think I already told you that we must have a concrete, and this concrete, you know, that's to make sure that we call it that concrete is not we call it weathering based on rainfall or sunlight, and you can find out after 10 years, after 20 years, after 40 years. Okay. Number two, they may be destroyed through construction or etc. Of course, that during the construction, your marker or your peg will be destroyed by the tire of steamroller, by the lorry. That's why when you have a marker, you are fence it. You are protected with a fence, and you put it in the red color to make sure that the driver, they don't, we call it hit your marker on site. Okay, so normally we put red, yellow, orange, and we give some protection because this control point or the peg is really useful when or during the construction, because you will use it before we start and after you finish, and during construction also you want to do we call it a setting up a new building, setting up a new site. So you must have this we call it pegs to become your control point on your side, to become your crucial frameworks, or to become your reference. Okay, so this reference you must be protected. So the third one is important that they be referenced by creating ties. Creating tie means that something like this, station to station, you are connected by a line. Okay, and make sure all this we call it station. For example, so station 1 to station 2, 45 degree. Station 1 to station 2, 3, 4, 5, 6. Station 1 to 6. Maybe the angle is 101 degree, 20 minutes. Okay, so based on these two angles, you know that they include angle reading. So you minus 101, 20 minus 45 degree 0 minute. Or when you are minus, you can get, we call it included angle. The included angle is here. All right. So there is it's important that they be referenced back to the tie. Lastly, with the tie, the point can be re-established. Sometime like this. Okay, I erase this one first. I erase this one first. So we're going to erase. Erase. So let me erase first, because I want to draw a new one, and hopefully that's we're going to erase again, right? Okay, right? Try to introduce. Okay. Okay. So the last one, we draw first. With the tie, the important can be established. Something like this. You have one point, point A, point B, point C you miss out. For example, point C you miss this one. You miss A, B, C you miss D, and you have E. Alright? So you can connect this one. But you know C is the connection, because you have traversing from B to C, D to C. So based on this intersection, you know the point C. So this intersection happen and guide by bearing distance. Bearing distance. So that is a good example when you, we call it left out, or mean that your point C is missing. So you can retie by re-establishing from point B or D. Alright, that is the point. Okay, next, we are going to next slide 25. Okay. So, it is something like you have, we call it the station. Maybe this one is station A. You take a detailing, fire hydrants, take mango tree, you take durians. So, A is your control point. So, fire hydrant, mango tree, durian tree is your detailing. Still remember? Detailing. So A may be going to B, B to C, C to D, D to E, E to F, F to A. So that is traversing. Alright. We go to next slide. Okay. Let me erase first. I don't know, this software is have problems because I cannot erase. I don't know. Maybe we call it, what happened, I don't know. Because this one, it should be erased. Let me finish my business first. Again, I go for erase. It's not working, I don't know. Okay.
Try to unmute it.
It's okay. So maybe you can we call it read it. If prismatic compass is being used, okay, in the survey, the observed clockwise, horizontal angles and vertical angles are measured using the compass. Okay, that's it. The distance between station will be measured using tape. It's very easy that you have bearing and distance, and your bearing measured by compass, measured by theodolite, measured by we call it total stations, but the length you measure by tape. Okay, and if you have a total stations, so your angle you measure by total station, the distance you measure also by total station using a laser to make sure that the laser push it to the target and the target will reflect back to the total station. The total station will calculate the distance. So that is the automatic. So this is example of booking. You have instrument at point A, okay. Then your target station at point E, and from A to point B, you observe horizontal angle, you observe vertical angle, and you observe the distance. Okay, next. So angle misclosure. Normally, if you have, we call it a traverse. You have a traverse A to B, B to C, C to D, D to E, E to A, B, C, D, and E. The total number of included angle, okay. So the total number of included angle, the formula is here. N minus 2 times 880 degree. So the angle outside one, we call it excluded angle. So the formula is here. N plus 2 times by 180 degree. External angle and internal angle. External here, internal here. So this one internal. This one internal. This one is internal. This one is internal. This one is internal. The outside one like this one is the external. This one also external. This one also external. This one also external. Okay. So hopefully that you understand what I'm trying to say. Okay. So we go for we call it traverse competition. Okay, let me traverse competition. Okay. The usual step followed in the making elementary traverse competition are number one, adjusting angle direction to fix geometric conditions. Number two, determining preliminary bearing of the traverse line. Number C, calculating the easting and nodding and adjusting from the misclosure. Lastly, D, computing the rectangular coordinate of the traverse station. So after this, you can see that all the process involved. Okay, in the part one, prismatic compass. You can see this one. But if you don't understand, you can tell me. I will help you after this recording class. Okay. So you remember that forward bearing and then back bearing. Forward bearing like from A to point B. From A to point B. So there is we call it from A to point B. So that is we call it forward bearing. Forward bearing. So B to A is we call it back bearing. So mean that the difference between forward bearing and back bearing is 180 degree. Okay, because it is in one line. You already learned in the mathematics. Okay, so there is we got the calculation, and this is the booking form. All right. The booking form, you see that station A to B, you have this angle. Station B to A, you have this angle. It should be A to B. The difference B to A is 180 degree. It should be 180 degree. But sometimes on practical, you cannot get exactly. So that's why we do the correction. When you want to do the correction, you must have booking. Okay, the booking procedure. Right. So the calculation is the different front bearing or forward bearing and back bearing is 180 degree. So we start with the station without error of local attraction and follow by next station. So we will learn after this. So mean that if you have, we call it for example that you have five station A to B, B to A. Maybe the difference is 181 degree. And then you have B to C, C to B. Maybe the difference is 170 degree 20 minutes. And then you have C to D and D to C. So the difference is maybe is 188, maybe 179 degree 0 minute. And then you have, we call it D to E, E to A. So it should be 180 degree, but you get 180 degree 30 second, 30 minutes. Then lastly, you have E to A and A to E. You get exactly 180 degree. So from A to E, E to A, the line we consider is right. So our calculation start from this point. From that point is 180 degree. We call it this one correct, no correction, and the measurement is right. Okay. Okay, continue. Station C and D station have no local attraction so that the observed bearing, or for example, this one, station C and D. When station C and D, so when we observe, for example, that C to D is 45 degree and D to C is should be 180 degree plus 45. Okay, because it's different. Okay, 180 degree minus 45. So you get this value. This value is the D to C. So the angles, or we call it the difference, must be 180 degree. So when in your calculation you find out 180 degree, or we don't have nearby 180 degree, for example that 180 degree 30 minutes. So this is the starting point where you do the correction as a references to the correction. Okay. So let's me try, we call it again to erase. I don't know either this one is a problem or what. Okay. Attention. If so mean that if you found this problem, where is it? Wow, we missed that point. We are in a slide number this one. If you found that after elimination of local attraction, so some of the final bearing are not giving 180 degree differential between forward bearing or forward bearing and back bearing, there are some discrepancies occurs. Discrepancy means that our measurements for that works, something is not right. Okay, we cannot say not right, but the accuracy is less. Okay, because in survey, especially in compass observations, we don't have any efforts to make sure the lines, the difference is 180 degree. So that is the facts. Okay, we go for the slide number 37. Slide number 37. Let me adjust the view. Let me adjust the view. It's too small, I think. Okay, relationship between forward bearings and back bearing. So, in O circle bearing, back bearing and forward bearing is plus minus 180 degree. You can have exactly 180 degree or more than 180 degree, maybe 181 degree or maybe 130 degree, 30 minutes, 30 seconds. For the conventional bearing, the force and back bearing are numerically equal in opposite directions. The forward and back bearing are numerically equal but in opposite direction. There is the quadrantal system. Alright? Still remember that we call it a two bearing, whole circle bearing and quadrant bearing. Quadrant bearing we have four quadrants, and four quadrants that show that first quadrants on your right tops. You can see that from north going to the east. Right? So you have also north going to west. At the lower part one, you have a south. South to the west and south to the east. Still remember that? So we have two systems. And for the quadrantal bearing or system, the fore and back bearing are numerically equal in opposite direction. I try to make it marker. Okay. Example, north is replaced by south or vice versa, and E is replaced by W or vice versa. Example, if the force bearing of line north 30 degree east, it means that north to east. So its a back bearing will be south 30 degree west. Okay, so this is different between the relationship bearing, forward bearing and back bearing in this two system. But normally we just discuss in this system the relationship between back bearing and back bearing in the whole circle bearing system. Alright. I think we already learned this one example. Convert whole circle bearing, back bearing. I think this one is. Are you familiar with that? And source of error? So we go in source of error. So what is the, we call it, makes our survey is error. Okay. So we have many things that the survey will be error. Number one is equipment. So maybe your needles is a bend. Maybe your equipment is, we call it, cannot give you, we call it the flat surface. And maybe your observation, you say that 20 degree 0 minute, but actually 20 degree 30 minutes. But you want to make it simple, so mean that you are doing a less precision, and sometimes you are observed. Sometimes the compass, they have, we call it the focus point. They have, we call it the observe lens. So you observe the object not in the center, and then you read the readings. So maybe the degree is 20 minute, 20 degree, 30 minute. But when you through the observe, you put in your object, target here, maybe your reading you write, you read 20 degree, 0 minute. This one is wrong, this one is right. Okay, so local attraction, you know that compass, you don't have, we call it puts any things that magnetic can pull out the magnetic north and east, north and south. Mean that if you are doing a survey, avoid the mental nearby you. But we cannot avoid, for example, at we call it the BJ Timah mines, the tin mines in Batu Gajah, at Kampung Gajah in Perak. So the compass is not work. But even though not work, at that time they don't have any equipment, for example, that Tedolite auto station, they still use a compass to complete the survey. Local attraction, we are looking at local magnetic sources. Okay, Step to reduce discrepancy. Step that you should take and count. You must give some priority in SOP to make sure the compass must be level at every session. So you must adjust by using your hand. You tilt up or tilt down based on your palms and some based on your finger. And you see, we call it a leveling bubble. The leveling bubble is really important to make sure that your compass level. So when you adjust, you see uh, the we call it the spirit level, left or right, and make sure the spirit level on the center, and then you stop. And nowadays the compass they have two bubble. One is left and right. The other one is we call it up and down. So you can see, make sure that two bubble, the air bubble at the center of the indicator. Okay, eye position should be level to the vertical plane. I mean that when you observe your eye, make sure that you observe very clearly. Mean that you should bend your body to get this position. So you must bend your body. Slightly knock the compass after doing observation, especially to the old one. If your compass may be 5 years and above, sometimes the needle stuck. So what you do is you knock, or in Malay we call it jentik, to make sure the needle is in rotation. And if the needle not rotation, please, we call it tilt up, tilt down, to make sure the compass in level condition. The last one, observation reading must be taken several times. For example, that we have session A, you observe to session B, make sure you read 3 times your two readings. One is bearing, number 2 is your horizontal distance. Because 3 reading, sometimes you read first one and the second one is different. The third one also different. So what is the final? Normally we put an average of the reading. We divide it by 3. So for a compass is small, light, easy to carry and cheaper compared to the other equipment such as Teroline, easy in surveying. A bearing on the line is free from discrepancy of another line before and after. Work can be done very quickly. But remember that compass is disadvantage is less accuracy, less accurate compared to using Teroline, always have local attraction. Compass always used for the recognition, less accurate specification or surveying, to take offset from the bend or the curve or the. Okay, so there is example that you observe the value from side. So station A, you get this value. Station B, you get this value. But this value actually, what we call it, this one is, remember that this one is station A. Go for station B. Station A going to the last one, F. So there is, we call it sudut dalam, included angle. So you see this one, when you have the include angle like this, so when you calculate this one, the total is 720 degrees, 0 minute, 0 second. So you remember that n minus 2 times 180 degrees. So how many n you have? A, B, C, D, E, F, 6. 6 minus 2, 4. 4 times by 180 degrees. So you get 720 degrees. But based on your observation, when you plus all this one, you get, we call it, the reading is not 720 degrees. You get this one. So 790 degree, 57, 0 second. So from this total, you minus with this original one. So you get the correction is 0 degree, 30 minute. So 0 degree, 30 minute, you divide it by 6 because 6 is because the station is 6. A, B, C, D, E, and F. So you get every station, you must do correction about 30 saat, 30 seconds. So you put here 30 seconds. Why 30 seconds? Why plus? Because your last reading 780 degree 57 is less than 720 degree. 720 degree is your actual. This one is your reading data. So the actual minus by reading data. So you must have a negative. You are surplus. So to make sure we call it, put it, make sure it's stable, you must put every observed bearings to the new correction. So minute plus 30 second plus 30 second plus 30 second plus 30 second. When you plus this one, you get this value. You plus this one, you get this value. You plus this one, you get this value. So this is the adjusted value we are doing in the office, not on site, because this on site we cannot get the right example. Okay, now we in slide number what? Here is 48. You give me maybe a 1 minute. I want to adjust. I want to erase this one. So wait for me. Okay, let me open a new one for the chapter 3. I'm start sharing first because I want to do some correction. Okay, you wait for a while. Because I'm going to, again we call it 48. Our slide, 48. Yeah, I got it. Again, I show with you, we call it the slide. So still recording is very good. I start to again represent my entire screens. I click on the entire screen, I say share. Okay, now sharing, I going back to this one. So can you see this one? Is it clear?
Yes, Doctor.
Okay, all right.
Clear.
Yes, of course, very clear. So this is your corrections, all right. Okay, let me go for, we call it another icon draw. So we go for draw and draw, okay. So this one is observed value on field. We calculate, we call it an office correction, and this is the right value it should be, because we have theory saying that A to B, B to A, the line must be 180 degree. Okay, next we go for 48, slide number 48. Okay, the following interior angle was measured in a closed traverse. The bearing of AB was measured as 60 degree. Calculate the bearing of all other line if angle at A is 140 degree 10 minutes. So mean that include angle at point A is 140 degree. Included angle at point B is 99 degrees 0 minutes. Included angle at point C is 60 degree 22 minutes, and included angle at point D is 69 degree 20 minutes. So here we go. Next slide, please. Okay, so when you are mapping, this one is a text and now it's become a graphic. You can see it's very clearly. So the 60 degree is here, right? So 60 degree is a bearing, and 140 degree is your included angle. This one is your bearing, or we call it forward bearing. 140 degree is your included angle, 140 degree. So your station A to D is 140 degree, 10 minutes plus with 60 degree. 0 minute. So you get 0, 10, 10. Almost this one. So A to D is you get what? 4, 10, 1. 200 degree. So A to D is 200 degree 0 minute. So that is how you calculate. Okay. So you also can calculate this one. B to C, C to D. I calculate with you D to A. So you can calculate. Alright? Okay. So for example that you have 60 degree here. You also can know that 60 degree here. B to A mean that the difference is 180 degree, right? Okay. So now we have 60 degree. Alright. So what the difference of angle when you minus with 60? So you get 180 degree. So you plus 60. 0, 8, 6, 4, 2. So 240 degree minus 60 degree. So you get 180. Mean that the angle from this one is the bearing B to A is 200 what? 240 degree. Okay, this one is back bearing. 60 degree is the forward bearing. I think you can know this one, right? The relationship. Okay. So we go for the next slide. Example, determine the value of equilibrium angle in the closed compass where traverse A, B, C, D conducted in clockwise direction, giving the following four bearing of a representative line. Okay, we have station, we have front bearing, we have back bearing. Front bearing also we call it four bearing, and we have main front bearing. Main front bearing mean what? So we assume one of the observed bearing is true. So we're assuming that maybe a front bearing or the back bearing is true. So we can calculate the main front bearing. Okay. So for station 1, 2, and 3, we have four bearing, back bearing. It should be 180 degree. And we have main bearing. Mean that we try to average between front bearing or four bearing and back bearing. Okay. Alright, next slide. So we calculate this one. 339 degree, 0 minute, 0 second minus 157 degree, 0 minute, 0 second. So you get 182 degree, 0 minute, 0 second. And you assume that four bearing is true. You assume that four bearing, this one, is true, is right. We assuming, if we not assuming, we cannot calculate. Okay. So back bearing must be added plus 2 degree to get 180 degree, 0 minute, 0 second, because we try to do some correction based on theoretical. 180 degree is theoretical. This one or this one is a practical. You're going to feel on site. This one theoretical. You just working in the office or home, right? So mean that back bearing 157 degrees, 0 minute, 0 second plus 159 degrees, 0 minute, 0 second. You are average it divided by 2. All this one you divided by 2. So you get the mean bearing 158 degree, 0 minute, 0 second. And if your back bearing is 158 degree and is less than 180 degree, so what we should do, you must have plus. So when you plus this one and this one, you get 338 degree, 0 minute, 0 second. Okay, local attraction, you must know that local attraction normally is straight by, we call it stainless steel poles, maybe we call it your tie pin, maybe a car, maybe a lamppost that can have, we call it, pulling the magnetic compass to their directions. Okay. So, and then because of, we call it, magnetic attractions, mean that your reading is not right. So you must do the calculation. So local attraction is detected by observing the forebearing and back bearing. If it's not in 180 degree, mean that you have local attraction, whatever reason, and sometimes it's not local attraction, you are misread the reading from the compass. So difference must be 180 degree, but it's more than or less than mean that you have a local attraction. Okay? If not, the discrepancy may be due to, if not, the error or the less accurate because of an error in observation, or either for and back bearing, for example, that should be 32 degree 20 minutes. What you write is 20 minutes 32 seconds. You are, we call it, first come left, the last, first come become last, and the last become first. Present of local attraction and either of both of the station. Present of local attraction. Attraction means that you have many things that local attraction later we will discuss. Okay, you look at this one. So this one is, we call it the observed bearing. So the search for the AB and BA mean that it should be 180 degree. When you look at this one is 169 degree 45 minutes. It should be 180, right? It's less than 180 degree. Another one, BC to CB, again less than 180 degree. It shows that local attraction is occurs. And the right one is 180 degree between CD and DC. D is the right one. So we should start calculation from this one. From this one. And then we have, we call it DEED, less than 180 degree. Then we go EAAE, less than 180 degree. It shows to us clearly that in the exercise, just one stations, CD and DC, give you the right value. So mean that no correction. So you put here CD no correction, DC no correction. The angle this one is maintained. The angle this one is maintained because no correction, no correction. No correction, no correction. When you finish this one, for CB also you put no correction because we consider this one is fine. And for DE also, we manage to get 0 because we consider this line is right. So if this one, no correction, mean that 219, you copy here, 219. When you minus to this one, so you must do the correction. The correction is like this. So 5 degree, 30 minutes. So you get 39 minutes, 0 minute, 0 second. When you minus this one, you get 180 degree back. Okay, this one also same. You have 162, no correction, 162. 162, you minus with this one, you get this value. You plus back this one, you get 342 degree. Because this one will not adjust. Okay, we not adjust. We don't adjust. We just adjust this one. Again, we couple up this one and this one. We arrange this one and this one. So you get a new correction like this. So all the column at local attractions, we put the corrections. Either the correction is going to positive, either the corrections be going to negative. And both positive, negative is based on your bearing. And your bearing is from the practical, it's not from the theory. Of course, we cannot get exactly 180 degree due to the local attraction. And we finish about the part 1 of what we consider as a compass. Now we are going for the part 2 is a theodolite. Alright, so when we are going to theodolite, first, this is the category of traverse if you are doing traversing, and then we call it, you can go for the first class traversing when your maybe that's your error is 1 to 100,000. Mean that in 1 mn, your error in 100 meter, that you measure 100 meter, your error just 1 mm. So we consider the first order of first class traversing. Right. Okay, and then we also had the precise control traverse. So when you consider the precise control traverse, or you want to do the first class traverse, you must have this. Number one, precise control survey. So lines up to 1 kilometer, you must use infrared EDM or prism as reflector. You cannot do a theodolite or compass. Then, because of your equipment is very good, so you get what? You get the high result. Angle I measure with at 1 second to the light is the high precision. Maybe the equipment, the price is 100K for one auto station or the light with the laser infrared EDM. Normally used for the large construction project. For example, that when you want to build up a bungalow, so no need for the precision, high precision. Use just only normal light. So we have category of traverse, so less accurate up to 250 mile lines. Use with steel band tape. What you use now in we call it. You still remember that we are practicing. We had the practical sessions at
Bateri doktor habis ya doktor? Oh, okey.
Ya itu.